NGTS-10b is the closest orbiting hot Jupiter ever discovered. This gas giant is 20% bigger and twice as massive as Jupiter. And it zooms around its 10-billion-year-old parent star so closely and quickly that its year only lasts 18 hours. When a planet is so close to its star that a year is 25% shorter than an Earth day, that planet is probably scorchingly hot. And NGTS-10b is getting roasted. Luckily, its star is 1,000 degrees colder than our Sun, and 70% less massive. But, to scale, the planet is 27 times closer to its star than Mercury is to the Sun. So the average temperature on NGTS-10b is only around 1,000 degrees Celsius, 1,800 degrees Fahrenheit. But since it's, probably, tidally locked, the temperatures differ wildly between the permanent day side and the permanent night side. As we see it today, NGTS-10b could be serving the very last portion of its death sentence. In only 10 years, astronomers might be able to watch NGTS-10b's final death dive, as it spirals into its star's fiery bosom.
Galactic collisions invoke images of destruction. And even though galaxies may be torn apart, and stars flung into space, collisions also ignite a mass birthing of stars. The earliest example comes from when the universe was a youthful billion years old. Even at the dawn of time, galaxies were already locked into a chaotic celestial mosh pit. Two of these galaxies, located 13 billion light-years away, have crashed into a gassy blob known as B14-65666. The bigalactic blob isn't huge. Its two constituents combined are only about 10% the mass of the Milky Way, which is expected at such an early stage in space-time. But despite its size, the blob is 100 times more active with star birth than our own much more massive galaxy. Galactic pile-ups cause the compression of vast clouds of gas, triggering bursts of stellar birth by literally smashing stars into life.
Black holes appear to be surrounded by a calm donut-shaped disk. But in reality, black holes are vomiting superhot matter all over themselves, like a fountain. When presented with a golden corral amounts of gas and dust, even the most voracious black holes can't consume it all. The debris accretes into a disk of infalling gas, which plunges into the black holes more with ferocity. It's heated to millions of degrees and stripped into its constituent atoms and ions, which are expelled back into the galactic environment. Some of the black holes throw up escapes into space and is never seen again. But some of the insanely hot atomic gas is pulled back in by the insurmountable gravity to continue the cycle, circulating like water through a city fountain.
Clusters of galaxies are zipping through space at millions of miles per hour. Sometimes they smash into each other and merge. Some ridiculously rare times, 4 galaxy clusters combine into one of the most massive structures the universe may ever see. About 3 billion light-years from Earth, the universe is assembling a massive mashup of clusters called Abell 1758. Each cluster contains potentially thousands of stars, and they've all been caught in an irresistible gravitational embrace. Abell 1758 is split into 2 pairs of clusters. In the northern pair, the 2 clusters already swung by each other in the previous 300 million years. And they mixed their heavy elements together in a gravitational swirl, like a cosmic pinky swear, promising they'll reunite once again. The sonic boom-like shockwave from the ancient encounter revealed our innermost planet, Mercury, orbits the Sun in 88 days. But numerous observed super-Earths complete an orbit around their stars in just a few days. And now, new evidence points to a strange phenomenon that sends unsuspecting planets hurtling toward their Sunday solar system. Formation is, not surprisingly, tricky, with many forces at play. Magnetic forces, collisions small and large between swirling bodies, and good old gravity are among the primary shapers. And when conditions are just right, these forces can push multiple planets into a conga line toward their star. The disk of particles that planets are born from, and the planets themselves, occasionally get locked into synchronized orbits. This resonance occurs as the planets and disk push and pull on each other. And the planets go tumbling inward. They gradually migrate to the inner reaches of their solar system, ending up in an orbital berth that's too hot and barren to form planets.
Speaking of bad things happening to the Small Magellanic Cloud, SMC, it's dying before our eyes. Some galaxies die glorious Viking deaths, torn apart by the gravity of some more massive object. But the SMC is dying a slow and undignified death. Even though the 200,000 light-year distant SMC is one of the farthest objects visible to the unaided eye, it's still not massive enough to retain all of its gas and dust. So it's quickly hemorrhaging its life support, hydrogen gas, into space. The galactic assassin is gravity because the SMC doesn't command enough of it. For every single star that the SMC produces, it loses 10 times that amount in gas. But the SMC may yet enjoy a warrior's death and earn its place in galactic Valhalla. Researchers believe it will be absorbed by the Milky Way before it dissolves into nothingness. Many other small galaxies will not be as lucky.